notes that I gave you several weeks ago. Who knows, 2-3 weeks ago. I don't even know now. Yeah. We need to review these, though, because it's been a while. We had already gotten to the point where we had graphed domain and, we had graphed cosine and sine. Remember, cosine looks like a cup if it's positive. And I want you to notice these special points on here. We hadn't been really mindful of those yet, but we have to be the further we get into this. When we talk about the sine function, notice that it starts on the oscillation line, and some of you highlight that line. I always highlight that line, and that's where my curve starts and ends for the sine function, okay? So we have 3 and 4, and I'm just going through this pretty quickly. You've already got the notes on this, okay? Because I gave you those. The transformations, though, we need to look at. We have only begun to shift these vertically, up and down that y-axis. And it gives us the horizontal line of oscillation here. And then we talked about, and you've already done a couple assignments on this. Is this written? Let's look at example 1 is done for us. Look at example 2. Just out of curiosity, just to refresh, where is the line of oscillation for? It's at -1. Now, I would like that to be rewritten so that my vertical shift number is at the end. And when I draw that -1, whether you draw it with a solid highlighted line or a dotted line, it doesn't matter. But where does that line, it's the sine curve, where does it start? It starts at -1. Okay, and I always draw one above, one below. Because this curve is going to, will it rotate up or down to begin with? It's going to rotate up, so it's going to go up and then down and then back up. Okay? And that's not perfect, but it'll do. Now, we've already talked about domain and range. I'm not going to go over that. How about example 3? Where's my oscillation line going to be for here? Well, I already have it drawn in. It's going to be at +2. And then, what's going to happen to that curve? It's going to rotate down. How do you know that? Because it's a negative. Now, will it go all the way to the x-axis? No. It's still only going to go down 1 unit and up 1 unit above the oscillation line. Something like that right there. Do you guys agree with that? Okay. And then, how about cosine? Well, again, we got to rewrite it. It's going to make it easier in the long run. Oscillation line is where? At 2. And then, is this going to be a cup or a mountain? It's going to be a cup because cosine is positive. So it starts 1 unit above the oscillation line. And folks, it does not look like a smile, nor will it look like a frown. Please draw the curve correctly. But it's just going to start 1 above and go 1 below. So it'll have a maximum value and a minimum value. Are you clear on that? Yes or no? Okay. So then you have example 5 at the bottom. Oscillation lines where, folks? At 1. All right, and I can see the line in here now. And we've got 0, we've got 1, we've got 2. And is this going to be a cup or a mountain? A cup or an uncup? An uncup. It's going to start at 0, and it's going to go up and then back down. Okay? Please make sure it does not look like that. That is not the curve. Okay? That's a frown. That's a frown. Don't do that. Okay? Yes? Well, for our purposes, we're only graphing one cycle, which is one period of that curve. So we are stopping it from dot to dot. In reality, in real life, does it go on? Yes.
Yeah, but if we did it not stopping
It needs to stop at the dot. It needs to stop, yeah. It will become more clear, hopefully, this week. Okay? All right, so let's move on. Let's look at some more transformations. Okay, this is new stuff, so pay attention. Really don't care, to be quite honest. D is our vertical shift. Okay, that's what we've been doing the whole time. That creates our oscillation line. We have to look at, and we're going to look at this stuff in order. If there's a negative sign in front of the function, of course, that means it's going to rotate down, or it's going to be opposite that normal curve we've seen, okay? So it means that there's a reflection of the curve about the oscillation line. We are going to focus on amplitude first. What is amplitude? All right, if you look down here, and I've got everything else labeled, these are the different types of, we're going to make the curve wide. We're going to stretch it tall, so it will be really tall and skinny. We're going to change the length of the curve where it's not one complete revolution around the unit circle. It may only just be a half of a revolution. We're going to do all kinds of things to it, but this is what we can do. We can change the amplitude, which is it's going to be a coefficient in front of sine or cosine. And this can be sine or cosine. This is the basic format for all of it. And then you're going to have, we're going to look at the coefficient in front of x, and that's going to give us the period change. What that is, it changes the length of the curve. It shrinks or enlarges the curve cycle, the width of the cycle. And then C is phase shift. That's the last thing we go over. And it'll be a couple days before we go over phase shift, okay? But we're going to do this in order. We went over vertical shift. You know how to move it up and down the y-axis. Now we're going to look at amplitude today. Amplitude. If you have a function is equal to a number in front of the trig function, whether it's sine or cosine, the A, if we take the absolute value of A, it's going to tell you how many units above and below the oscillation line, how high and how low the curve can get. Because up until this point, we've only gone 1 unit above and 1 unit below the oscillation line, right? This is going to change the height of each of the curves, okay? Now, let's look at period change. We're going to look at both of these today. Period change is this number right here, okay? It says the period tells the width of the cycle of your curve, and the period, you need to make sure you put a box around this. Highlight it. The period is always 2 pi divided by that coefficient. Always. Yes, ma'am. They might be over there on that table. I don't know. Because everybody should have these. Okay? So if we were looking at the equation, y equals sine of 2x, okay? I want you to look at this. We're going to take the 2, and the first thing we need to do, and you'll see this more with all the problems that we work, we need to look at the amplitude. And I want you to write that in, okay? The amplitude is the absolute value of A. It's the absolute value of the number in front of the function. Well, what number? It's there, but it's not there. 1. So the absolute value of 1 is 1. Okay? Is this curve going to be reflected? Yes or no? Is it going to be reflected? will it rotate downwards? How do you know? Because it's positive. Okay, so it's not reflected. The amplitude is 1. And the period, which is 2 pi divided by that number, what's 2 pi divided by 2? Pi. So that means the length of the curve is going to be 0 to pi, not 0 to 2 pi. Let's see here. Let's take a side track. Let's take an exit, okay? Side ramp. On a sheet of paper or over there, let's do it on a separate sheet of paper. If I would have given you this curve, okay, let's say that you have sine of x plus 1, okay? This is easy. What's my oscillation line? 1. And since I don't have a highlighter, I'm going to draw this with a dotted line. Okay? There's my oscillation line. And my sine curve's going to start where, y'all? At 1. And it's going to go up 1 unit and down and then back up. Do you guys agree? Okay. Now, the thing that I did not force you into doing, and I told you, I said it's going to make a difference, but I knew that anyway, was we never labeled our x-axis, okay? What we should have done, and what we're going to do now on this problem, is we're going to label the cycle. 1 revolution around the unit circle is from 0 to 2 pi. Do you guys remember? You know that. You know that. This point in the very middle, what's in the very middle of our revolution? Pi. And then if I were to cut that in half, what's half of pi? Yeah. Or pi over 2, right? All right, so what's going to be here between pi and 2 pi? 3 pi over 2. Now, relate that back to the unit circle, okay? 0, pi over 2, pi, 3 pi over 2, 2 pi, right? Do you see where these values are coming from? It's coming straight from the unit circle. Here's 1/4 of the way, here's a 1/2 of the way, here's 3/4 of the way, up here's 1 whole revolution. So this is what we should have been doing, and I want you to notice what these values are. Notice that the maximum value occurs when x is what? Pi over 2. The minimum value is at 3 pi over 2. Do you guys see that? And doesn't that make sense? I mean, if you look at the unit circle, where's our maximum value? At the top. At what angle? Pi over 2. What's our minimum value on the unit circle? 3 pi over 2. I mean, if we're looking at literal maximum, you know, what's the tallest, what's the shortest value, then it is pi over 2, and then 3 pi over 2, of course, is our lowest. Now, which I think is kind of cool. Now, how am I going to relate that back to that problem we just looked at? This changes the period. This doesn't mean any longer that this curve is going to go from 0 to 2 pi. Now it's going to go from 0 to pi. And we still have to cut it in half. Cut it in half. What's half of pi? Pi over 2. This is where you got to know fractions. Okay? What's half of a half? Pi over 4. A fourth. Okay? And then, folks, look. 1/4, 2/4. What's your next increment? 3/4. How appropriate. Bless you. Bless you. And then 4/4. 3 pi over 4 and pi. Does that make sense to you? Do you see how we increase those increments by pi over 4 units? Yes or no? Okay. These values, I don't know if that came out. These values change since your period changes. I don't know if that's in your notes or not. These values change since your period changes. It's on my paper, but I don't know that it's on yours. It's okay. All right, so let's look at this next one, okay? Because you're going to have to do this every single time. And you start at the beginning, and you go right down the line of your equation. First thing you need to ask yourself, the first thing we come to, is this function going to reflect, yes or no? How come? It's not negative. It's a positive 3. So it's not going to reflect, okay? The next thing we come to is our amplitude, okay? Our amplitude is the absolute value of A. Well, we've got to find the absolute value of what? 3. What's the absolute value of 3? 3. All right, and we're going to show you how that's going to work in just a second. And then the period, remember the period is from the number that is directly in front of the x. What number is directly in front of the x? Directly in front of the x. 1. It's there, but it's not there, right? So our period is 2 pi over 1, which is 2 pi. Now, where did that come from? What the crap? All right, go back and look. Your period is 2 pi over b. 2 pi over that number. That's where that came from. 2 pi over this number right here. Okay? What are we going to do with it? First thing you need to do. Hey, is there a vertical shift? No, there is none. So what's your oscillation line if there's no vertical shift? The x-axis. All right, so here we go. I'm going to highlight, but not highlight. My oscillation line is the x-axis. Now listen very carefully. From the oscillation line, my amplitude stretches the curve. So that means from the oscillation line, my maximum value has to be 3 units from the oscillation line, and my minimum value has to be 3 units below the oscillation line. That's because of the amplitude, because of the 3. Okay? And then the period is 2 pi, so then that's when we put in 0 to 2 pi. And then we throw that middle value in there, pi. We throw the quarter value in there. This one's pi over 2. And then 3 pi over 2. And this is going to make more sense when you have to do this on your own, when we start from scratch. This one, I gave you the curve, okay? Example 2, we have to do that one on our own, okay? Go back to your blank sheet of paper. Let's do another one like this. I think it's next. So what is this going to be? Example 1.5. 1.5, okay? Let's go with f of x is equal to 2 sine x. And we're going to take this in baby steps, okay? We've got to name everything we can about it first. And if you go in this order every time, it's a piece of cake. Does this curve reflect, yes or no? No. Does not reflect. How do I know? Because it's a positive 2. Okay? Next one, amplitude. How do I find the amplitude? Absolute value of A, which is 2. What's the absolute value of 2? 2. All right, that's going to be helpful to us in a second. The next thing, period. It's 2 pi over something. Why? Because there's nothing in front of the x. So if there's nothing there, it has to be the number 1. It's our invisible 1, which makes the period of this curve 2 pi. It's going to be 2 pi. That's the length of the curve. Okay? Is there a vertical shift? No. Where's the vertical shift always? It's at the very end, and there's nothing there. So, is there, and we're going to do that example next, okay? Is there a vertical shift, yes or no? No. So that means my oscillation line is what? Is the x-axis. I'm telling you, the more notes you give yourself within your notes, the better off you're going to be. Now, here we go. Sine curve. Okay? Where is our oscillation line? It's the x-axis. Let me see if I can do this. Okay. All righty. Here it is. All right, there's my oscillation line. The amplitude tells me what? How high and how low. How high is this curve going to go? It's going to go 2 above. And it's going to go 2 below. Do you guys agree with that? Yes or no? Okay. So that means my maximum value is going to be somewhere up here. My minimum value is going to be somewhere down here. Do you guys agree with that? This is exactly what I have to do. The first time I taught this, I thought I was going to pull my freaking hair out because I did not get it. And the more I graph these, the more I get it. But this is exactly what I have to do. Where will my curve start? On the x-axis. So here we go. I'm going to go up to that value and then down and through my minimum value and back up. Thereabouts. Okay? Now, I've got to put my x values onto my x-axis. So it's running from 0 to what? 2 pi. And then I always go the middle, take half. What's half of 2 pi? Pi. What's half of pi? Pi over 2. And then 3/4, look, 1/2, 2 halves, 3 halves, 4 halves, which is 2. Does that make sense? Pardon? And here's a suggestion. Those of you using notebook paper, use the marks, use your lines as your your units of measure. Don't do your lines in the middle of those. Use the blue lines on your notebook paper. Why wouldn't you?
So the period just tells you how far you're going out?
Yes. Because we're only looking at a section of that sine curve, and we're only looking at 0 to 2 pi for this.
Could it be anything else?
Yes, it could be something else. Okay? Let's look at example 1.6. Because if we have a 1.5, we have to have a 1.6, of course. And y'all, the easiest one to look at is their sine curve. Why? Why is that the easiest one to work? I think it's the easiest one to work with. Because it starts and stops on the oscillation line. So, what? here we go. -2. Sine of 2x plus 1. Okay. Let's go through this one together, and then I'll give you one to do by yourself, because this one's got it all, almost. First thing, ask yourself the same thing every time. Is it going to reflect? Yes. Amplitude. How do I find the amplitude? Absolute value of, which is -2. What's the absolute value of -2? Of course, it's 2. And then period, which is 2 pi divided by who? Which 2 are we talking about? The second one. We're talking about that one right there. 2 pi over 2 is pi. Does this have a vertical shift? Yes, which means our oscillation line is where? That 1. Very good.
What's the last part mean?
The vertical shift? That was the first thing we did like a week ago. It moves the oscillation line. Okay? All right, here we go. Let's see here. First thing you need to put on your graph is what? The oscillation line, which has to be where? At 1. Okay? 1, 2. So here it is. Here's 2. Hey, with respect to my oscillation line, this curve is going to go how high and how far above and how far below the oscillation line. How do you get that, Tiffany? Because of the amplitude. All right, so that means that my graph is going to show that I'm going to go up to 3 and down to, okay, 0, -1. All right, now, let's think about this. This is going to start, my curve is going to start where? On the oscillation line at 1. And Holden, is it going to rotate? Is it going to go down or go up first? It's going to go down to what number? It's going to go down to -1, back up to 3, and then back down to the oscillation line. Right? Vontae, you cool with this? Okay. Here we go. Now what do we have to put on our graph? We got to label the x-axis. So it's starting at 0. It's going to pi. My halfway point is, what's the half of the half? 1 pi over 4. And then 3 pi over 4. And guys, I'm telling you, if you'll write below it, if you are anal about things and you don't want to make careless mistakes, then go 1/4, 2/4, 3/4, 4/4, and make sure that you have those increments correct. How many of you are like, because half of pi is, and look at it this way. What is half of pi? Mathematically, how do I figure that out? 1/2 times pi over 1, which is pi over 2. Yes? Okay? Why aren't we labeling 0, pi over 4, pi over 2, 3 pi over 4, and pi on the oscillation line? Because we've got to label the x-axis, and the oscillation line is merely a tool to help us draw our curve. That's all. That's the only thing I'd use it for, is it helps me determine where my curve starts and how high and how low or how far below that line it's going to go. Okay? What's going to happen? Let's look at another one. I want you to do this one from beginning to end. Example 1.7, here we go. F of x is equal to 3 sine 4x plus 4x minus 2. I want you to do that one, and if you need to work with someone in front of you, beside you, behind you, you do that. But this one you're doing by yourself. Will it reflect, yes or no? No. Amplitude, what is it? 3. It is 3. Absolute value of 3 is 3. Period. 2 pi over who? 4, which is pi over 2. That's different. Vertical shift. My oscillation line at -2. All right, so I'm going to move my x-axis a little bit up my y-axis because I want to account for 1, 2, 3. How far do I have to label my, okay, and then 0, 1, 2, is that right? Is it okay if I go that high? Yeah? All right, so you said my oscillation line's at -2. Okay, there it is. And my sine curve starts at my y-axis on the oscillation line. No rotation downward, no reflection. So I'm going to go up. What's my maximum value going to be?
1.
It's going to go up to 1. And it's going to go down to -5. Somewhere about right here. And then back to the oscillation line. I put these dots there as just guides for me, okay? So I'm going to go up and down and then back up. And my curve is never going to look the same. If I draw it 4 different times, it's going to look like 4 different curves. Now, what else do I have to do? I have not going to label my oscillation line. I'm going to label my x-axis. So I've got 0 to who? Pi over 2, isn't it? Do we label the oscillation line? No, I just said that 5 minutes ago. I love you. We don't label the oscillation line. We have to label the x-axis. Because my oscillation line is just a what? Tool that I use for me to graph my curve. Pi over 2. The middle value is going to be what? What's half of a half? Pi over 4. And what is half of a fourth? Okay, now, think about what I'm asking. What's half of 1/4? 1/8. Okay? So it's pi over 8. And then think. 1/8, 2/8, 3/8, 4/8. So my 3/4 of the way across is going to be 3 pi over 8 because 4 pi over 8 is equal to pi over 2, isn't it? How many of you had this correct? Every piece of it correct. Very good. Well, yeah, all except. Did you have the x values correct, yes or no? Did you go up enough and down enough? Folks, I'm going to tell you what. This test can make or break you. Once you get it, it's fine. But I'm telling you right now, you better figure this stuff out. And I'm going at a snail's pace teaching you this. Okay? Please Ask questions if you need to. Do not sit there in silence and be satisfied with not understanding. I don't know. I mean, you know, I'm not going to have everybody here. We're going to have one out tomorrow. Thursday's clubs. Next week's Thanksgiving. Who knows? Yeah. Yep. Other questions on this? Marking the x-axis. You know that it's based on the period. All right, that gives me the value that I have to get to, right? What I'm doing is I have to break it down into 4 chunks. So here's your first chunk, second, third, fourth, right? If I find half, do you see what I did up here? Half of. When I say the word of in math, it means to multiply. So I want to take 1/2 of 1/2. Okay? 1/2 of 1/2 is 1/4, which is what gave me this right here. What's 1/2 of 1/4? 1/8. That gave me that. And then I realized, Megan, that I'm going 1/8, 2/8, 3/8, 4/8. Does that make sense? No? Let's see. All right, do you understand why I'm going 1/2 of 1/2, which gives me this value? I'm going 1/2 of 1/4, which gives me this one, right? And then once I realize that this increment is 1/8, then I'm adding 1/8 each time. 1/8 plus 1/8 is 2/8. Okay, which is equivalent to pi over 1/4, right? And then 2/8 plus 1/8 is 3/8, right? So I'm just adding increments of 1/8. 3/8 plus 1/8 is 4/8, which is equivalent to 1/2. Do you see what I'm doing? Positive. Need more practice. Need more practice. Okay? Anybody else have other questions on this? Okay. All right, so let's look at another one. Which curve have we not looked at? Cosine. Okay. Let's don't do 3x. Let's go with let's go 4x. Okay. 2 cosine 4x plus 1. All right, here we go. Hey, out of curiosity, let me just show you something. No, I'm not going to. Let's keep going. Here we go. Reflect. We write the same stuff every time. Does this thing reflect? No. Amplitude. Absolute value of what? 2, which is 2. Period. Is always 2 pi over which number? The number directly in front of the variable x. 2 pi over 4 is pi over 2. Does this have a vertical shift? So that means that my oscillation line is at 1. Yes? Okay. So here we go. Is this going to be a cup, an up cup, or a down cup? All right, it's going to be an up cup. So I'm going to draw it up. So hey, up is a U, folks. See the U? Up, cup. Ha, 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 ha. Here we go. You're welcome. I know. Here we go. Oscillation line's at 1. I got to move this thing. Got to ungroup this. All right. Now, oscillation line's the first thing I want to draw in. So I'm going to draw it at 1. That's at 1, 2, 3, 4. We got 0, -1, -2. And I'm just randomly labeling my y-axis. Now, where will this up cup start? From the oscillation line, the maximum value is going to be how many above it? It's got to be 2 above it. So here's 1, here's 2 units above, so it's going to start at 3. That means if it's an up cup, this is not, you're not going to find this on Google or anywhere, an up cup and a down cup. That means the other side of my curve will be up here at 3, won't it? Where will my minimum, how come? Because you have to go 2 below. So it'll be in the middle. Very good. Megan, go ahead with your question. No. I just put it there. All right, now, this is not a U. This is a beautiful, smooth curve. Beautiful, smooth curve. Beautiful and smooth. Yes, it has to start at the y-axis. And can it go beyond the y-axis? No, not unless there's a phase shift, and you haven't learned about that yet. Okay? Later. Later. Hey. Here we go. Let's label our x-axis. This curve is running from 0 to what? Pi over 2. What's the midway? Pi over 4. No. I mean, if I were to ask you that, you ought to be able to tell me where it runs. No. No. This is what you're going to be doing on these problems. You've got to tell me all of this information over here on the left, and you got to be able to graph it on paper. That's it. Questions? Not yet? Okay. All right. Okay. Let me cut the recording off. If you look at this last example, down here on example 5, it's on your paper. But folks, I want you to notice something. Notice that this value right here is 1/2. All right, so when you figure the period, it's going to be 2 pi divided by 1/2. Okay? So I had to go old school, and I figured out 2 pi divided by 1/2 is actually 2 pi times its reciprocal 2, which meant that the period was 4 pi. And look how we labeled. We went 0 to 4 pi. Well, what's half of 4? 2. What's half of 2? 1. 1, 2, 3. How many revolutions around the unit circle would that be? That would mimic 2 revolutions. But they're kind of, look at the curve, okay? I just want you to notice if you get a 1/2 or any fraction in there for the b value, where we go 2 pi divided by that value, that it may give you an even number, which is fine. It makes it really easy, okay? Just be aware of that. The rest of it's the same thing we've been doing. The only weird part is that 1/2. Now, here's what you're going to do for me for homework. Guys, on this 5 through 8, 11 through 13, and 15, you need to write exactly what we did. Reflect, amplitude, period, vertical shift, all of that stuff, and then draw your curve and label your graph appropriately.